Hi, what's up, guys? Today, let's look at the Lintcode number 115, unique passes 2. This question actually is a follow-up for unique passes, which I already go over in last video tutorials. So in this problem, actually, we just added some extra conditions. Now we have to consider the obstacles. And in this grade, actually, 1 represents the obstacles. So that means we cannot reach. So based on this condition, so our question remains the same. How many unique passes would it be? Let's look at this example. We have a 2D array, and from top left, from 0, 0 to the bottom right, how many passes are there? So right now we have a 1 obstacles in the middle, so we can just only bypass the obstacles. We can go from here and we reach the target, or we can from here we reach the target. Now our answer will be 2. We only have 2 possible unique passes. So that's the follow-up. So how do we do this? Basically, the overall strategy remains the same. We're still going to use the dynamic programming. And if you don't know that, you can just go to my last video tutorials. And I'm also going to just do a side-to-side comparison. So with this new condition introduced, actually some parts need to be changed. DP initialization is fine. But for this DP element initialization, we need to change a little bit. Because in last video tutorial, we just initialize the column 1 and row 1. We just initialize them to be 1 without considering anything else. But in unique passes 2, we need to check if this this current element, if this current path is an obstacle or not. If it is not obstacle, it's fine. We just can initialize to be 1. But if it is obstacle and we have to break, why do we have to break? Because after the obstacle on the row 1 or row 0, I should call it row 0, and on the column 0, it's gonna the elements will not be accessible after the obstacle, right? If you draw a graph, then you will realize that. And same thing for a column, for row. So it's all the same. So we need to check if that data point is obstacle or not. If it is obstacle, then we have to break. So this is the changes for initialization. And second change is inside these for loops. And in 1 and 4 unique passes, and in the 2 nested for loops, we just directly write our state transfer equations here, then that's it, right? But here we have to consider the obstacles. So we need to check if this is not obstacles. Obviously, we can just apply this state transfer equation. But if it is obstacles, then we have to mark it to be 0, because there's no way to reach obstacles, right? Obstacles point. So the DP obstacles point will be 0. So that's the only changes which happen in initialization and in for loops calculation. So return, we still return the DP n-1 and n-1. So that's it. Not that complicated. Just add the conditions, all the concept, all the core techniques. It's still the same. All right, so let's run this. Okay, looks great. Looks great. All right, thanks. Yeah, you have a good one, and I see you in next video tutorials. Thanks.